Black holes are one of the most powerful and energetic objects in the universe. These massive objects can have a mass tens of billions of times that of the Sun. In the early 20th century, Einstein predicted that gravity is a distortion of space-time. He also predicted that massive objects moving through space-time should generate ripples, like waves moving through the ocean. Even when you walk, you leave tiny gravitational waves that compress and expand space around you. But it would need an extremely energetic event to produce waves that we can detect. When two black holes come close to each other, they cannot escape each other's gravity, so they merge. The collision sends ripples through space-time, or gravitational waves. Events like this are extremely violent, and gravitational waves triggered by them are noticeable here on Earth. When such waves finally reach the Earth, they are extremely weak, but they provide us with specific information that light cannot give. The masses of the two spiraling objects, their spins, the location and distance from Earth, are all imprinted onto the signal recorded by the gravitational wave detectors. Gravitational waves are invisible, but they are extremely fast. They move at the speed of light, 186,000 miles per second, and as they travel through space, they squeeze and stretch anything in their path as they pass by. On September 14, 2015, LIGO, short for the Laser Interferometer Gravitational Wave Observatory, detected gravitational waves sent out from a pair of colliding black holes. An interferometer is basically a laser-based measuring instrument that can detect gravitational waves and locate their origin. These waves came from two black holes, each about 30 times the mass of our Sun, that merged to form a single object 49 times as massive as our Sun. The extremely energetic event, which released 50 times more energy than all the stars in the observable universe, lasted only fractions of a second. This was the first direct measurement of gravitational waves ever, as predicted by Einstein. Because the waves LIGO detect have a frequency that's comparable to the range of frequencies we can hear, scientists can pump up the volume and translate them into sound. But the final result is nothing you would expect. Take a listen. These cosmic ripples speed up in frequency and rise in amplitude as the black holes merge, then quickly die down once the merger is complete, creating a kind of cosmic chirp. What's interesting is that as you listen, you are hearing remnants of black holes that collided into each other some 1.3 billion years ago, in a galaxy far, far away. When black holes collide, they just create a more massive black hole, and this is the event that sends gravitational waves around the cosmos, detectable across more than 1 billion light years.
To get this weird sound, the researchers used light signals collected at their detectors in Livingston, Louisiana and Hanford, Washington. The Gravitational Wave Observatory is technically a telescope, but it doesn't look like any telescope you have ever seen. The Blind Telescope provides scientists with their first glimpses of literally unseeable wonders. LIGO, which is run by a group of scientists including some from NASA, MIT and Caltech, is the largest gravitational wave observatory. It consists of two widely separated interferometers within the United States, one in Hanford, Washington and the other in Livingston, Louisiana, and are operated in unison to detect gravitational waves. LIGO uses a setup with laser beams, light detectors and mirrors to detect the faint shortening or lengthening of long distances that occurs as gravitational waves ripple through the Earth. Scientists say this dual observatory is on the same level of complexity as the Large Hadron Collider at CERN. Analyzing information brought by gravitational waves is allowing us to observe the universe in a way never before possible. Before LIGO, just about everything we knew about the universe came from studying waves of light. Now we have a new way of observing the universe by studying waves of gravity. LIGO is liable to make discoveries that will impact quantum mechanics, astronomy, relativity, and even nuclear physics. As always, don't forget to like, comment and subscribe to the channel, and please go support us on patreon.com/cosmoknowledge.